I want to look at 3.2, number 7. I've had some emails with questions, and I noticed that this was a highly missed problem. So let's go ahead and look at that. The problem that I have is this one. So it says the brain volumes of 50 brains vary from low of 916 to high of 1498. Range rule of thumb. Use a range rule of thumb to estimate the standard deviation S and compare the result to the actual standard deviation of 176.5, assuming the estimate is accurate if it is within 15 centimeters cubed. So we first need to estimate the standard deviation. I've already found that, but I wanted to show y'all where this is in our notes. So if you go to 3.2, let me pull up my notes. Range rule of thumb, okay? And it says if the standard deviation is unknown, you can estimate by dividing the range by 4. So we are going to do that on this problem. Then we're going to compare it to our actual. So they said in the problem that they vary from a low of 916 to a high of 1498. So what this, 98. There we go. So what this actually means is this is our min value and this is our max value. There's 50 brains, n equals 50, but actually we don't really need that, but it's there. What we need to do is use the range rule of thumb to estimate, which was range divided by 4. So I would take 1498 minus 916. I'm going to divide by 4. 1498 minus 916 divided by 4. And what it says on the paper, on the assignment, it says do not round. Use the exact. Okay. So this is our estimated SD or S, standard deviation. And what we're doing is we're comparing that to the actual. They said that the exact from our assignment, from that worksheet, was, let me see, exact is 176.5. And we're comparing those. So to compare them, we're going to subtract. So we're going to do the 176. It doesn't matter which order you do. I'm doing it like this so that I get a positive, but honestly, it doesn't matter. But that does come out to be 31. So that is how far apart, that's how they compare. And the key word here is we are going to compare the result to the exact, assuming the estimate is accurate if it is within 15. So this value, 31, is greater than the 15 that we're saying is accurate. 15, anything under 15 is considered accurate. Anything greater is considered not accurate. So that means the approximate is not accurate because the error is greater than 15. Okay, so that helps you on number 7. So let me do the next problem. Next problem is number 8. The brain volumes of 20 brains have a mean of 1056.8 and standard deviation of 120.9. Use the given standard deviation range rule of thumb to identify the limits separating values that are significantly high or significantly low. For example, would a brain volume of 1,308.6 centimeters be estimated significantly high? So I need to write down the important information. So mean on this one is this. And our standard deviation is this. And it says use the range rule of thumb to determine what our limits are. So looking back at our range rule of thumb that we did our notes, we have the usual values, the unusual values. We would look at x bar minus 2s and x bar plus 2s. So x bar plus 2s is going to be our max, and x bar minus 2s. So this would be minus. And then you do the same thing, but adding them. So I'm going to use my calculator to do that. So 815. And then I'm going to go up here and just switch out. So what this means, if I were to put this on a number line, my mean goes in the middle. It's going to be 1056.8. And then 2 standard deviations would be right here. It's 815. 2 standard deviations above. So right here is considered usual, and anything beyond is considered unusual. So think of this as a number line. So there'd be 700 here, there'd be 1400 over here. So let's look at what the problem says. Significantly low values are, so that would be 815 or lower. Significantly high values, that is the 1298.6. So is this significantly high? So it's in our unusual area. So yes, it is, because it's above the upper, or yes, because it's below the upper, or below the lower. No, it's above the upper. And the other yes would be yes, because it's between. No, anything between them is not considered significantly high. But if it's above the upper, then yes. Okay, so that should help you with question 8. Number 10 was the next one. Let me pull that up. Sample is taken, and this is of the blood pressure. Values are matched so that there's 10 subjects. Find the coefficient of variation for each of the 2 samples, then compare the variation. So we need to do the coefficient variation. So let's look through our notes. So our coefficient of variation, this is still on 3.2, it's right here. And we have samples. We don't have the entire population. It says a sample. So it's S over X bar times 100%. So we have the systolic. We want to find X bar and we want to find S for both of these. And then we need the diastolic. We need to find X bar and we need to find S. And then once we do that, then we can find the CV of each one by doing S over X bar times 100%. Same thing here. So we're going to have to use this data. So I showed y'all in the calculator how to do the data to find the mean and standard deviation. So let's go to stat. Let me move this up. Go to edit. I'm going to clear out what's in here. I'm going to put that in. So I'm going to put them in separately to get my mean and my standard deviation. So I need to make sure I did it correctly. Okay, so I found all the values. So now I'm going to go back to stat, over to calc, one var stat. And so for the systolic, my mean is 127.3. Standard deviation is 18 point, let's do, just because I need it to be as accurate as possible. You're not supposed to round to the very end. So in order to find my CV, I am going to do S, so 18.18 divided by 127.3. And then times 100%. So really I'm moving my decimal over. What am I going to round to on here? Let's see. Type an integer or decimal rounded to one decimal place as needed. So that'd be so I'm really moving it over two places. So that would be 14.3. Let's see if that's correct. Okay. And so then the other one, you're going to do the same thing. So go back to stat, edit. I'm going to go up to L1 and push the clear button, which is right here. Push enter. And then put in the diastolic, 80, 78. Make sure I done correctly. Then you go to stat, calc, one var stat. Okay, so X bar is going to be 73.9. And then S of X. So I'm going to do as many as possible. Then I'm going to do my CV, coefficient of variation. So I'm going to do S divided by my mean. And I'm going to move it over two places. So it's 16.4%. Okay, so compare the variation. The coefficients of variation for each set are they within or are they more than 5% apart? Well, look at them. It's like 2.1. So it's within 5%. So therefore they vary about the same. If they're within 5 percentage points, they vary about the same. Okay. Let's look at our last question that I want to do, and that's number 13. According to a random sample at 12 a.m., body temperatures bell-shaped with a mean of 98.31 degrees Fahrenheit, standard deviation of 0.67 degrees Fahrenheit. Using Chebyshev's theorem, what do we know about the percentage of healthy adults with body temperatures that are within 2 standard deviations of the mean, or the minimum and maximum? So let's look back at our notes. What do we know about within 2 standard deviations? Here it is. At least 75% of the data will lie within 2 standard deviations of the mean. So we want the min. So in order to find this, we are going to do 2 standard deviations above, 2 standard deviations below to find out what those values are. So we're going to do x bar minus 2 standard deviations for your min possible values, and then your max possible values is going to be x bar plus 2s. So you're going to use these two numbers that they gave us. So 98.31 minus 2 standard deviations. 96.97, and then we want to add 2 standard deviations to the mean. Okay, so those are the numbers that we're going to put in. 2 decimal places. And so those were the most missed problems. So if you want to go back and correct those, I'll let you even get all your points back for that.